Alright, today our focus is on something called literal equations. So when I say literal, I don't mean like the English word literal. I mean equations that have multiple letters in them, or multiple variables. We tend to use letters. You can use different things other than letters. It's just easier with letters. When you solve a literal equation, you're just rearranging the equation to isolate the variable that you want. So let's give this a shot. So we're going to solve each of these for y, and we're going to work our way up in difficulty. So for this first one, we're going to do it in columns. Okay? So in this first one, we're just going to, we have to undo subtraction, so we're going to add 4 to both sides. So I end up with y equals 8 plus 4. Yes, there's a reason I'm leaving like that. So we could end up with the answer of 12 if we wanted to. Here, instead of add, we're going to subtract 6 from both sides. And I get y equals 10 minus 6. If you really want to, you can write 4 as your answer. Over here, we're going to solve for y again. Well, last time, to get rid of a minus, we added, so we want to move the x because the thing we're trying to solve for is y. I'll go ahead and highlight all my y's in my equations. So I want to add x to both sides. So I have y equals, now this time they're not like terms, so I can't add them together. So y equals 8 plus x. Last time when we were adding, we subtracted 6 from both sides. So this time we're going to subtract x. I just don't know what x is, and that's fine. So I end up with y equals 10 minus x. Alright, on this next one we're going to practice it again. We're just going to add x to both sides. And I end up with y equals w plus x. That's fine. It has all letters. They weren't like terms, we couldn't combine them. Alright, right here we're going to subtract x from both sides. And we end up with y equals z minus x. Again, that's fine. We didn't have like terms, there was no combining. On the first two problems, we had like terms. We could come to a single solution, a single number. But in those ones, we couldn't. Alright, we're going to continue to solve for y. So I'm going to highlight all my y's again. If you haven't noticed, we just continue the same pattern. So we're going to start on the left and work our way right. So here we have 5 times y. We have 5 times y. We're just going to divide to get rid of that 5. And we get y equals 20 over 5. If you want to reduce, you could in fact get 4. On the next one, though, it's not so easy. We have x times y. So we need to divide by x to cancel out that x. That canceling out still happens. However, because 20 and x aren't like terms, we can't just do something easy, so we're just going to leave it as 20 over x. And finally, on the last one, when we divide both sides by x, we end up with y equals a over x. And that's fine. It's just perfectly fine. Alright, on the next one, we're dividing by 3 when we start, so we're going to multiply both sides by 3. So we end up with y equals negative 6 times 3. If you really wanted, you could leave this as negative 18. On the next one, we have an r on the bottom, but that's okay. It doesn't screw anything up. We can just multiply both sides by r, leaving us with y equals negative 6r. And again, we're going to do this one more time. We're going to multiply both sides by r, and we have y equals negative tr. Okay, I want you guys to go ahead and try these ones. Remember that you are solving for y. You've got this. Once you're done with that, your turn to try these ones as well. Here you're solving for w, then x, then h. Pay attention to which one you're solving for. Then we're going to finish off with solving for whatever it specifies. So we'll do solving for y, and we'll come back and then we'll solve for x as well. Alright, I'll see you guys in a second.